on our review today, or the bell work today, the input was for number 1 was -4. And what did we get when we plugged in a -4? -11. So technically we could have a point -4 comma -11 if we were talking about wanting to graph the solution or that value for that value. Number 2, what was the input? What did we plug into the variable? 3. When we plugged 3 in, we got an output of 7. So, and then on number 3, our input was -2 because that's what we put in for the variable. We simplified and we got 1 as the output. Okay, so for each one of these, even though we only got one output, we have one domain, one range. The domain is what we let our variable equal. In number 1, it was -4. Number 2 was 3. And number 3 was a -2. The range would be the output, what we got when that variable was a specific value. So hopefully that helps a little bit with your understanding on domain and range. And we will be working with this when you're in maybe a little bit in geometry, but a whole lot in algebra 2. Okay, so just hang in there. All right, so now we're going to talk about, there's another name for the input variable, and it's called the independent variable. Okay, and then the output variable is called the dependent. Okay, so why is it called independent and why is it called dependent? Well, if we go back to our bell work, we don't know what 3x plus 1 is until we know what x equals, right? So the value for 3x plus 1 is going to depend on what x equals. So the independent variable in this case on our bell work was x. We know what x is. We don't know what 3x plus 1 is until we plug that in. So the expression 3x plus 1 would be like the dependent variable, the output. Okay, so the first one's not done here for you, but we're going to go over it. So how much Sam earns when he makes $15 an hour? So what do we have to know? What are we wanting to know?
How much he earns.
How much he earns. And that depends on what? How long he works, right? So if you just say it in that sentence, what he earns will depend on how long he works. Then we can write as our dependent. The amount earned depends on the number of hours worked. So that gives us our dependent and independent variables right away. We can go ahead and fill in the independent variable is the number of hours worked. And then the dependent is amount that that person's going to work. So let's talk about an equation for this. So what do we want to call the number of hours worked? Because we don't know what that is, right? We don't know the amount earned, but we don't know the number of hours worked. So our independent variable is going to be, we want to define it first, bless you. So Taylor, give me a variable for that we would want to use for the number of hours worked. X. Okay, so we're going to call the number of hours worked X. So put above that, put an X. How do we know how much that, who is it, Sam, earns? How are we going to figure that out? If he makes $15 an hour, what do we need to do to figure out how much he's going to earn? If he works 3 hours, how much is he going to earn? $45. What'd you do, Josiah? Multiplied the number of hours he worked times what he earns per hour. So his earnings, we're going to call that Y, depends on the number of hours worked. So we could write this as, I know there's not a whole lot, we're going to write out to the side, Y equals 15x, because what he earns will be the product of $15 times however many hours he works. And then to change that, this is called standard form right here. If we wanted to make it a function notation, then we would write it like this. Hold on to your seats. So the top one is standard. The bottom is function notation. And it's function notation because we have this f of x out front. So it's saying I have a function, and in order to evaluate that, the function rule is you're going to take 15 times whatever x is to get the output. Okay. All right, let's look at the next one.
Does that mean anything?
What do you mean?
Well,
Okay, good question. So what if we wanted to know, what if he worked 3 hours? Because we said he works 3 hours, then how much will he earn? Well, the difference is, instead of saying y equals 15 times 3, we would write it like this. We want to know what the output of the function will be when x is 3. When our input is 3, what will we get for the output? So then we would write it this way. We would say f of 3 equals, and wherever we see x, we put that 3, and that would give us $45 in this case. So, does that answer your question?
Yeah.
Okay. All right. So here, when we were just doing like ordered pairs, that was just kind of getting ready for things. Now we are at the big dance right there when we talk about function notation. Okay. All right, let's look at number 2, the cost of a bunch of grapes at $1.19 per pound. So, what would we probably try to figure if we're buying grapes? The cost of them, right? So, that's going to depend on how many pounds we buy, correct? So, in the first, you're going to put the cost of a bunch of grapes depends on the number of pounds purchased. So go ahead and write that in. So our equation in standard form is that y equals 1.19x. X being the pounds, right? And then the function notation would be f of x equals 1.19x. And then we said we're buying how many pounds? 5. So what would be the output for our function if our input was 5? Somebody do that on their calculator for me. Did somebody do that on their calculator for me? Sorry, I'm writing over stuff. You wouldn't want to do that. I just don't have a whole lot of room here. Okay, so now let's look at the next group. Here we have, we're rewriting each as a function, and we're going to assume that we want it in the form y equals. Okay, so let's look at the first one. It's done for you, but let's talk about how it got to be that way. So we have our 2y minus 2x equals 8, and we want to get y by itself. So we've done equations like this before where we're trying to isolate a specific variable. There's more than one variable, and we're trying to solve for it. So we want to get y by itself. And right now it's 2y. We want to get 2y by itself. So in order to do that, we're going to add 2x to both sides. And that gives us 2y equals, and I'm going to put my x first just because it's proper to put your variable first. 2x plus 8. And now I want to get y by itself. So what do I have to do to y to what? Divide by 2. So if I'm going to divide the left by 2, I have to take everything on the right divided by 2. So that means I'm going to take the 2x divided by 2 and the 8 divided by 2. And in doing that, that's how we get this first equation, y equals x plus 4. Because we get rid of the 2, we get rid of the 2 there, and 8 over 2 is 4. And then we just rewrite it as a function, f of x.
Are we trying to get y on one side?
Yes, we're trying to get y on one side by itself, isolating y
Why not all of these?
on all of them. So go ahead and try 4 and 5. Try to get y by itself on each of those equations and write it down, and then we'll compare together. All right, go for it. So all we do on number 4 is subtract 5x. We get y equals, we want to put our x first, so that's going to be a negative 5x plus 16. And then changing it to function notation, Kimberly, what is that going to be? But let's put the x first, the negative 5x plus 16. And we would say that f of x, okay? F of x equals a negative 5x plus 16. Good. On number 5, James, what do you think the first step is to get 4y by itself?
Divide the 4.
Before that, we got to get rid of that 8x. We don't want to do any dividing or multiplying until we just have y on one side by itself. So let's get rid of that 8x.
Add it to 16.
Yep. Add 8x over. So I'm going to do that actually above here. And then I get 4y equals 8x plus 16. Now I'm going to divide everything by 4. So that I can get just y. So I'm going to take that 8 divided by 4 and the 16 divided by 4 as well. So that gives me y equals a very messy 2x plus 4. Correct? Okay. So how would I say the function? How would I say the function, Tawny?
F parentheses.
How do you say that though?
F
F of x equals what?
2x.
2x plus 4. Very good. Okay, so yeah, you might have to do some of this work on a separate sheet. All right, let's move on down. Up above, we called the total cost y, right? And we called our number of hours worked x. So how much does he earn per hour? $60. So the equation that you're going to write is that the y, the cost, is going to be 60 times x, or 60 times however many hours he worked. And then we can rewrite that function as f of x equals 60x. And then let's go one step further. How much does he charge for 6 hours? So that would be where we would plug in 6 for x. So we would say f of 6 is 60 times 6. And 60 times 6 is 360. So he's going to charge $360 to work those 6 hours. Okay, so I want you to try to figure out number 7 on your own, and then we'll discuss it together. Nolan, what did you think? How did you fill out? The blank depends on the blank.
The cost of the drone depends on the set of extra propellers.
Yes, very good. The total cost will depend on how many sets of extra propellers he wants. No matter how many sets of extra propellers this person's going to have to pay at least what? $300. That's a flat amount that doesn't change depending on how many extra propellers. That's the cost just to get the drone. So we have to put that at the end. We have to put plus $300. That's a constant.